So I've cleared out the memory, my calculator, so its normal functions and settings. Okay, so I go to the mode button first. Okay, and when I click mode, the fourth row down here is where we have used a lot, going back and forth between radian and degree. Okay, we're going to keep it in radian. And then one beneath that, the row beneath that, it says function. We have always used our calculator in function mode, but now we are dealing not with function, regular rectangular coordinate functions. We're dealing with polar functions. So over here, I'm going to arrow to the right and hit enter to highlight polar. So I'm changing my calculator to polar mode. And then I'm going to go down 2 more rows. Here it says sequential. When we have normally graphed, if we're graphing more than one equation at a time, sequential, it will graph one and then it will graph the next and the next and the next, however many there are. But if I change it to simultaneous, that's what this is, it's going to graph them at the same time. I can watch them being graphed together. And that's the mode that I want to be in. So I want to be in polar and simultaneous mode and radian. Everything else can stay as is. Good? Once you have the correct modes, we're going to go to the window settings up here. Okay, we are working in radians. So notice it's theta, because we're in polar mode. We have theta. We want it to be 0 to 2 pi, which that's 3.628. And then the step here. The step, what this does, if you clear this out, is, there we go. The larger the number you have for the step, the faster the graph is going to graph and the more jaggedy it's going to look. Okay, this is saying how often you want a point plotted. Okay, so the smoother, more accurate you want the curve to be, the smaller you want this number to be. And especially for what we're doing today, we're trying to watch the path of the graph. We want it to go kind of slow so we can watch it. So I'm going to set this at 0.01. Okay, so that's 1/100th of a radian. It's going to plot a point every 1/100th of a radian on the graph to give us a nice curve. Our X minimum and maximum, the screenshots that you see on your paper are set, excuse me, for -5 to 5, but it doesn't matter if you leave those -10 to 10, it'll just be a little more zoomed out. So I'll let you decide. I'll change mine so it matches what the paper says. So -5 to 5 by 1s for both the X and Y axis. Okay, so we set our modes, we've set our window, and now we're going to go to Y equals and put our equations. And notice it's not Y equals because we've switched it to polar mode. It says R equals. So we're going to put in 2 polar equations. Okay, and they're written there on your paper. The first one is what type of shape if it's 2 + 2 cosine of theta? What shape is that? That's a cardioid, right? It's a type of limison that comes back into the pole. For theta, to get the theta here, it is the same variable key that we use to get X. You'll notice on this button, there's X, T, theta, N. What variable shows up when you push this button depends on what mode you're in. When you're in polar mode, it's going to show a theta. So 2 + 2 cosine theta, and that's the same button as we usually type for X. Okay, and you said that one would be a cardioid. Okay, the second equation is 2 - 4 sine theta. What shape is this going to be? Say it again. It's a limison, but when the A value is less than the B value, what happens? It's an inner loop. So this is going to be a cardioid and a limison with an inner loop. Okay, now you'll notice on the paper I gave you, we want to watch this be traced. So we're going to come over here to the left of the equation, right here. Now yours doesn't have the color. You don't have the, unless you personally have the color version. But when you hit enter here, you can change the line, like how thick it is, or if it's dotted or dashed. I want you to change it to this symbol right here. Okay. We're going to do that for both equations. Okay, so this is what your y equals screen should look like. So far, so good? So now we've got our modes correct, we've got our windows set up correct, and we've got our equations equal. We're ready to graph it. So you can watch, I'm going to hit graph, and we are looking for where the, like, pretend that the tips of these that are graphing, it's a plane flying, and it's just like a jet stream it's leaving in its wake, right? So we're looking for where they collide at the same place, same time, not necessarily just cross over a path that the other has already crossed. Does that make sense? So you're looking for a collision. So we're going to watch those graph at the same time. So no collision yet. There's a collision. There's one. Okay, and they're continuing to graph. It's going slow because I set it the step as 0.01, so it would go nice and slow and we could watch it. Okay, so where the blue one just passed over the red path, that's not a collision. They're about to collide over here again, though. So there's two collisions. And that's it. So we've got the blue cardioid and the red limison with an inner loop. I know the graphic on the paper I gave you, it shows, I think, a positive sign limison. Accidentally, it's the wrong screen grab. This is what it should look like. But do y'all understand what I mean when I say you're looking for the where they collide? Does that make sense? Okay. Because it looks like here, you're like, oh, they intersect here. But they don't actually intersect here because they weren't here at the same time. Does that make sense? Uh-huh.
It's graphing the one that.
Did you, on your mode, go back to mode, does yours have the simultaneous selected here instead of the sequential?
Oh.
That's what, if it's sequential, it's going to graph one and then the other. It has to be in the simultaneous mode to graph both at the same time. Mine took kind of a long time. So here, let me show you. If I go to the window and I change my step to a larger number, watch what happens if I change this to a 1. Because we're in radians. So if I only plotted a point every 1 radian, that's not that many, right? And so there's not going to be very many points plotted. And so it's going to look jaggedy and it's going to graph really fast. Watch. Like, that is not a very good look. That is not what your cardioid should look like. It should not be pointed like that. It's not showing the actual curve of it because it's only plotting 1, 2, 3, 4, 5, 6 points. Right? So if I change that step to 0.5, okay, it'll look a little better. Still not great. Still a little jaggedy, right? So that's why that step value, that theta step matters. So that's why I changed it to 0.01 so it would be nice and smooth and accurate, and it goes slow enough that you can watch it. 0.1's not bad. Like it's going to graph a lot faster, but it's still going to be relatively a relatively nice curve. So there's one collision, two collisions. So if you prefer to do 0.1, that's okay. Just notice it looks a little more pixelated up here. Do y'all see that? The smaller you make that step, the less pixelated and jaggedy looking it's going to be. It'll be a nice, smoother curve the smaller that theta step. All right, any questions about what I mean when I say collide? So that's what I'm going to get at on the back side here. So we got a nice visual. Watching the polar graphs being graphed, we can see where they collide. Those are actually where they intersect. Okay. Now, I can't do in polar mode the points of intersection like I do in rectangular mode, in function mode. So what I'm going to have to do to get those coordinates where they actually intersect is if you flip your paper over, well, you could go ahead and answer. There's a question on one side that says, count how many times the points collide. If you want to write down that it's 2 or highlight on your picture where it is, that's fine. Okay, but we're going to flip over to the other side and we're going to go back to our mode and we're going to go back to function mode. We can leave it as simultaneous, that's fine. We're going to go back to function mode and we're going to go back to our window now that we changed modes, okay? And I'm going to do a, if I'm in function mode and I'm graphing a trig function, a sine and cosine function, what's my domain going to be for like one cycle? 2 pi. Those equations, I'm going to type in the same equations, 2 plus 2 cosine x. Okay, it's going to show up as x this time instead of theta. And 2 minus 4 sine x. Okay, if you think back to unit 3 when we were graphing trig functions, you can visualize this. You can say, okay, this is going to be a cosine. The period hasn't changed. There's no b value. It's going to have an amplitude of 2 and a midline at 2, right? So you can get a visual in your head of what this is going to look like. So your window setting, the domain is 0 to 2 pi. So my x, minimum and maximum, that's what I want to be 0 to 2 pi. Okay, and then my y, we can do -10 to +10. That's fine. Oh, use the negative button there. There we go. I typed in 2 and then the pi symbol right here. I did second and then the caret key. And when I went off of it, it automatically changed it to a decimal. Okay, so these are the window settings I want for my sine and cosine graphs here in function mode. Because if I'm graphing them as a regular function, it's going to be that sinusoidal wave, right? So now we can go back to the graph. We can watch those be graphed, those sinusoidal waves, and we can see there's those 2 collisions. There's those 2 points of intersection where when we graphed them as polar graphs, those were the collision points. Does that make sense? So you can see it in polar mode. You can see them colliding, okay? But we have to come back to rectangular mode so we can calculate where that's actually happening. So now I can go to my calculate menu, which is second, trace, and then it's the 5th option, intersect. So second trace 5, and I get my little cursor and it says first curve. I hit enter it jumps to the second curve. I hit enter, and then it says guess, and I hit enter again. And then it moves to that closest intersection. And that's the coordinates, the rectangular coordinates of the intersection of those two curves. Now I know there was 2 collision points. So if I want to find the other one, I do the process again. I go second, trace 5. But before I start hitting my enters, I'm going to scroll over closer to the other intersection. I'm going to come closer over here and do my enter, enter, enter. And it's going to give me the coordinates of the second intersection. Now, how that relates back to your polar, you could then convert your rectangular coordinates back to polar coordinates, and those would be where those collisions are happening. I'm not going to ask you to do that. You don't have to do that, but you do need to be able to find these rectangular coordinates of the points of intersection for the polar graphs. Does that make sense, that process? So you have this paper, okay, that has like screenshots of all the menus and everything that you're supposed to have, how it should be set up. Okay, on the front and back are some practice ones for you to practice going through those steps and making sure you've got the hang of that process. Okay, so there's just like 4 problems on the side for you to try that with. And then after you get a little practice in with the graphs with technology, I want you to go to Delta Math. And you have a mixed practice on polar coordinates and curves. Okay, the Delta Math unfortunately did not have with technology practice, like practice finding those points of intersections and stuff. So that's why I put those are on the paper for you to go through and practice that process in your calculator. And then there's some practice on Delta Math with what we talked about like over the last week and a half. Do y'all feel okay about that? So y'all have the rest of class. If you don't have your own graphing calculator, I would do the calculator practice on your paper first, since you don't have a calculator at home, because then you can work on Delta Math at home. This is set to be due on Thursday before midnight. So you've got a couple, 2.5 days to get that done. I'm out Thursday for a golf tournament this week. It's the makeup for the one that was canceled before. But on Thursday, while I'm out, y'all are going to have a quiz over polar graphs and coordinates. Okay, so tomorrow we're going to do some more practice together. And then Thursday, you're going to have a quiz, and this Delta Math will be due on Thursday. So when you finish your quiz on Thursday, it's going to have a time limit set. It's not going to take the whole class time. It's going to be like a 20 or 25-minute quiz. And then when it's done, you can work on finishing your Delta Math, or I will then have our district CBA. We're finally going to have a day to look over the results from the fall semester exam on Friday. That's what we're going to be doing. But I'm going to go ahead and open it up. So Thursday, when you finish your quiz, you can start looking at your individual test results and seeing what you missed on the exam. So then Friday, when I come and we look at it together, you know what questions you have, and then I will show y'all data about like what were most missed and what the averages and everything were. Okay. And then next week, we'll continue on with this unit, and we'll start talking about parametric. Okay, so we're done. This was like the last thing on polar we needed to talk about notes-wise. We're going to quiz on that Friday, and then next week we have a couple more topics. We've got parametrics and vectors in this unit. If you're in physics, you may have already done some vectors, or if you had physics last year, maybe. And then we'll have that unit test in a couple more weeks. Good? All right. So you have the rest of class to work on that calculator practice, practicing that process. and or starting the Delta math practice.